Good morning, dear students. Our next chapter is coordination compounds. You can call it as complex compounds. Coordination, that means in these compounds, the bond nature is coordinate bond, coordinate covalent bond. So far we have studied ionic bond, covalent bond. So what is the bonding type? Coordinate bonding. That's why you can call it as coordination compounds. So what is the coordination compounds? Negative charge ion or neutral molecule or both. That means negative charge ion. So neutral molecule bind with the transition metals. What are the transition metals? D black elements, or you can call it a transition cations. Transition metals, metal cations, D black elements. So these D black elements combining with which one? Negative charge ion or neutral molecule, or it contain both negative charge and neutral molecule, through which bond? Through coordinate bond, to form characteristic compounds is known as complex compounds or coordination compounds. Once again, you will understand slowly. So when transition D black elements or D black cations, metal transition metals, D black metals, combining with which one? Negative charged ions or neutral molecules, or both negative and neutral molecules, through which bond? Through coordinate bond, to form characteristic compounds, is known as coordination compounds. So we will take one example, you will understand clearly. Chromium Cl6. So while we are writing, we will. So this one is a which one? This one is a transition metal. Transition metal. Cl is a which one? Negative ion. So what is the bond between these chromium and 6Cls? The bond between this is coordinate bond. Coordinate bond. What is the bond between chromium and Cl? Coordinate bond. So a special type of compounds, you are writing in the bracket, you are writing charges, right? So a special type of compounds, this compound is known as coordinate compound. Suppose if you take CO NH3 taken 6 times plus 3. Just for example, you will why you are writing like this. Slowly you will understand the this coming classes. So this one is a neutral molecule. This one is a transition metal, chromium, cobalt, D black elements, right? Transition metals. Ammonia is the neutral molecule. So the bond between ammonia and cobalt is coordinate covalent bond. Metal is having the vacant orbital. So this neutral molecule is having the excess orbitals. So this one donates the electron pair to transition metal. So through coordinate coordinate bond, that's why this special type of, due to donation of electron pair to transition metal, the special type of compounds are forming. These type of compounds you have to call it as coordination compounds. Coordination compounds. Suppose if you see, this one is the first example, second example, you can write third example, cobalt NH3 3 times, Cl 3 times plus 3. So in this one, cobalt is bonding with neutral molecule, cobalt is bonding with the negative molecule. So the bond between cobalt ammonia, cobalt Cl is the coordinate bond. So cobalt is the transition metal. This metal is having the vacant orbital. this ammonia and chlorine. What is the coordinate bond? So first of all, we have to define that one. So ammonia is having the lone pair of electron H plus. You have studied in the P1 chemical bond chapter, right? So it donates the electron pair to hydrogen. It forms the ammonium cation. So what is the condition? One must be having the lone pair of electron. One must be having the vacant orbital. Then only one component donates the electron pair to vacant orbital. The formed this bond is known as coordinate covalent bond. So how do you write? NH, 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 the bond. So these are covalent bonds. What is this bond? Coordinate bond. Coordinate bond. So what is this bond? Coordinate bond. What is the condition for coordinate bond? What is the condition? One must be having the lone pair electron. One must be having the vacant orbital. Then only it forms the coordinate bond. In this one also, transition metal is having the vacant orbitals. Negative charged ions are neutral molecules. This neutral molecule or negative charged ions are electron excess species that donates the electron pairs to transition metals through coordinate bond. Due to this donation, due to this formation of coordinate bond, the special type of compounds are forming. These compounds are known it as coordination compounds or complex compounds. This is what is the meaning of coordination compounds. So these negative charged ions, neutral molecules, generally we call it as ligands. We call it as ligands. So what is the meaning of ligand? Ligand is having the excess electron density, excess electron pairs. Electron donor. Ligand is having the ligand is a electron deficient species, electron excessive species. It may act as a both electron excessive or electron deficient species. Which one is the right? Ligand always electron donor species. Which one is the electron acceptor species? Transition metal. Transition, why transition metal? It is having the cation. Transition metal cations having the d black orbitals, vacant d black orbitals that takes the electron from the negative or neutral molecules through coordinate covalent bond. Right? A special type of bracket compounds. You are writing in the bracket. So why you are writing bracket? We'll discuss. So a special type of compounds you know it as coordinate compounds. Double salts and coordination compounds. Difference between double salts and coordination compounds. Salts, double salts are normal salts. So what is the meaning of double salts? KCl, MgCl2, 6H2O, double, two salts, or you can take KCl, single salt, any salt. So this one is one salt, this one is one salt, two salts. So generally you call it as carnallite. Right? Chlorine sources we have studied in the halogen chapter, carnallite. So what is the difference? If you add it in water, it completely ionizes. Complete ionization takes place. Complete ionization takes place. What is the meaning of this one? That means in the water, it gives the K plus ion, Cl minus ion, Mg plus 2 ion, like that. It completely ionizes in the water. Suppose if you take potash alum, K2SO4, Al2SO4 taken thrice, 24H2. In the water, it is also double salt. This is one salt, this is one salt. Combination of two salts, you call it as double salt. In the water, completely it ionizes. In the water, complete ionization takes place. What are the ionic compounds? In the water, once it ionizes in the water, what are the cations and what are the anions? K plus Al plus 3, SO4 minus 2. Completely ionization takes place. Suppose if you take NaCl in the water, what happens? It completely ionization takes place. It Na plus Cl minus, right? So double salts in the if you add it in the water, complete ionization takes place. Whereas in the coordination compounds, partial ionization takes place. Partial ionization takes place. Suppose in the coordination compounds. So in the water, if you add these coordination compounds in the water, it ionizes partial ionization takes place. Plus 3Cl minus, only Cl ionization takes place. In this one, only potassium ionization takes place. So need not to by heart at this stage, need not by heart this one. What you have to understand is the complex compound in water, partial hydrolysis takes place. That means 4K plus. This potassium ionizes, but in the bracket compound does not ionize. The bracket compound does not ionize. That is a difference between this one double salts. Double salt. What is the difference between double salts? Double salts are complete ionization takes place in the water. Complete ionization takes place in water, whereas coordination compounds partial hydrolysis, partial ionization, right? Partial ionization takes place. For this movement, the bracket compound does not ionize. This compound, the bracket compound, the spare bracket compound, this compound, the spare bracket compound, complex compound, coordinate compound, the complex means the spare bracket compound. This total compound you call it as complex compounds, but in that bracket compound does not ionize. The outside bracket compound ionize, it forms as a K plus. Outside compound, the Cl6 ionizes as 3Cl minus, whereas the bracket compound, the complex compound does not ionize. So that is the difference between double salts and coordination compounds. Some terms used in the coordination compounds. Frequently we use some terms. What are the terms? Central metal atom, ligand, coordination number, ionic sphere, coordinate sphere. So coordinate sphere, what is the coordinate sphere? The bracket, within the bracket, the elements you have to know it as coordinate sphere. Outside bracket, the elements known it as ionizable sphere. K4 is the ionizable. So this component is, if you add it in the water, this component can be ionized in the water. That's why you can call it as ionizable sphere. This component does not ionize, that's why you can call it as coordinate sphere. So what is the meaning of coordinate sphere? Central metal ion is attached to the ligand which is negative or neutral molecule, right? So are enclosed in the square bracket, collectively known as coordinate sphere. What is the meaning of coordinate sphere? Central metal atom combining with the ligand, that is negative molecule, negative atom or neutral molecule, right? So they collectively enclosed in the square bracket, you can call it as coordinate sphere. What is the central metal atom? The Fe, generally you call it as central metal atom. Iron, you call it as. I am taking one example, you can take any example, right? K4 is the present in the ionizable sphere. This one is the coordination sphere. So this one is the, you can call it as central metal atom. Central metal atom is surrounded by negative atoms or negative ions or neutral molecules or both. To give this a clear-cut geometry of that compound, that's why you can call it as central metal atom. Central metal atom is act as a Lewis acid, that is electron acceptor. It is having the vacant orbitals, so that's why it can accept the electrons from the ligand. So what is the ligand? Ligand is the Lewis base. Electron pair donor is, according to Lewis, electron pair donor is a base, electron pair acceptor is a acid. So central metal atom accepts the electron, ligand donates the electron. That's why metal atom acts as a Lewis acid. So that ligand acts as a Lewis base. Coordination number. How many number of ligands surrounded by central metal atom? How many number of ligands? It may be negative or it may be neutral or it may be both. How many ligands surrounded? You should not count outside the sphere. You should count within the sphere. Within the sphere, how many ligands are surrounded by iron atom? That call it as coordination number. In this one, how many are surrounded by iron? 6 Cn ions are surrounded by iron. So the 6 is the coordination number. The 6 is the coordination number. So coordinate sphere, that means within the bracket, metal atom, ligand are enclosed within the bracket, you call it as coordinate sphere. Outside the coordinate sphere, which is ionizable in the water, that's you call it as ionizable sphere. Central metal atom, that means the D black element which is having the vacant orbital, you should call it as Lewis acid. The ligand which is having the electron excess, you can call it as Lewis base. The number of ligands surrounded by metal atom, you can call it as coordination number, right? So based on this ligand denticity based on the denticity of the ligands are classified into different categories: monodentate ligand, bidentate ligand, tridentate ligand, tetradentate ligand, hexadentate ligand, right? So classification of ligands we'll discuss in the next class. Right? So correct. You can take one more example. There is no problem. CH3C, right? 5. So which one is the central metal atom? This one is a central metal atom. Which are the ligands? These are the ligands. So ligands, which one is this one is a neutral, this one is a negative. That will come in the next class. So how many ligands surrounded by the central metal atom? These are 5 and chlorine 1. So 6. What is the coordination number of this complex? 6 is the coordination number of this complex. This complex containing only coordination sphere. It does not containing any ionizable sphere, right? So coordination sphere does not ionize in the water. It will remain it will remain as such in the water. That means the iron and the CN still attached in the water. Still the bonding still present in the water. So you have to understand there is no cleavage of bonding takes place between iron and CN. The bond is still present when you add water in the when you add these complex compounds in the water. K plus ions are ionized. That means K plus ions are divided. In this coordination sphere, the iron still attached to the CN ions. It is still combining with the Cn minus. Cn minus does not go away from the iron. Still contact with the iron through coordinate bond. That's why it does not ionizable. You can call it as coordinate sphere. Alright. The classification of ligands will discuss in the next class. Thank you.